So let's look at a feature of Java that's called reflection. So reflection in the context of programming languages talks about the ability of a language to examine itself, right? So we want to be able within the language, within the programs that we write in that language, to be able to introspect, to be able to examine what's happening inside the code. So we can talk about the code from within the code, more or less. So that's what reflection means. So there are two parts to reflection normally. So the first part is to understand what's happening, right? So you might want to check at runtime what is the type of a variable, right? Or you want to check something of that kind, whether two variables have the same type. The other thing is to intervene, right? So you want to intercede, as it is called, intercession. So you might want to actually change something. If something is of some type, then change its type, right? So these are the two things that you typically would like to do if you have a reflective capability in your programming language. Find out what's going on, and based on that, take some kind of, so this action, of course, all programs do something at runtime based on the values, right? So this is not something as trivial as updating a value of a variable. It's more like changing the type of a variable, or creating a new object or something like that, right? So that's what we mean by interceding. It's not just something as simple as updating the value, which is what anyway a normal piece of code will do all the time. Based on the current flow of the thing, you might want to update a variable one way or another way. So that's not reflection. Reflection is really talking about some kind of structural change in the program that you perform as a result of what the program has done so far. So the simplest kind of reflection that we see in Java, which we have also seen in languages like Python, is you can examine types, right? So you have passed a parameter and you want to find out at some point what exactly that parameter is, and especially in a context of a language like Java, where we have this type hierarchy and we have this compatibility of types across this hierarchy. So we might at any point get something which is notionally of a super type but is actually of a subtype, and then we might want to ask, if it is of the subtype, whether we can perform additional operations on it, because the subtype will have more capabilities. But we don't want to do this unless we know for sure that the value that we have is of the subtype. So in this case, we can use this Java instance of to validate that the so-called employee E, which has been declared to be of a super type, is actually at runtime something more sophisticated, namely a manager. Now this is useful if we know in advance what we are checking, right? So when we write the code, we have some fixed types like manager and employee, and we want to know whether something which was declared to be an employee is actually a manager or not. But what if we don't know this? What if we generally want to check something about two arbitrary objects that are given to us, right? So supposing we want to do something as simple as validate whether two parameters that are passed to a function are both objects of the same class, right? So we want to write a function class equal, which will take two arbitrary objects and check whether or not they have the same class. So this is now written in this style, where I'm not using a generic programming thing, I'm using the class hierarchy. So any parameter, because it's compatible with object, can be passed for O1. Any parameter, so I can pass two dates, I can pass a date and an employee, I can pass a manager and an employee, and then depending on whether they're equal or not, I must say true or false. So how would one go about this? Well, we cannot exactly use instance of, because we don't know, unlike the earlier case where we knew that we were checking something was an instance of manager. Here we really don't know what we're checking for. We just know that O1 has a type, O2 has a type, and we want to check whether O1 and O2 have the same type. So O1 is an instance of some type, O2 is also an instance of the same type, but we have to run over all possible types, and we can't possibly know that because there are all the types that we are using, but we are of course importing and inheriting a lot of types which come because we are part of this Java tree under object. So the list of all possible classes and types which are compatible with object is not even known to us. So we can't even find out easily what we must check. So this is clearly infeasible. On the other hand, this kind of a test is not allowed, right? We are not allowed in Java to check whether something, compare it with a type variable. So we will see this, but for generic types, this instance of is not well defined. So we can't use generic types to get around this. So what can we do? So it turns out that Java provides this introspection, this reflective capability to ask questions about various things. So one of the things that we can ask is, what is the class that an object belongs to? So there is a function called get class. And where is this get class? It's in a package called reflect. So remember that we're talking about reflection. So Java has a reflect package. So if we import this package, then we have access to these functions which allow us to examine classes and do much more. So at the very least, what we can do is we can take O1 and O2 and we can get the class of each. So I can say O1.getClass and O2.getClass and compare them. If you remember in Python, we had this type. We can say type of x, right? And we can say something like if type of x is equal to, say, type of 7. This would tell us whether or not x is an int or not. We can compare two types. It's not so easy to, you need to know the syntax to know what to compare it to as a context, as a constant. But if you have another value of a known type, so you can just take an integer expression and its type will be of type int. You can take that type and you can compare it. So this Java can do with this get class. But this in Python, notice that this type thing is basically used for these built-in types. Whereas get class now tells us how to do it for user-defined classes in Java. So what does get class actually give us, right? When I'm saying get class equal to, what am I comparing? Is it the name of the class? Because that's what Python gives us. Python gives us a kind of a string which tells us something about the name of the class. So it turns out that the Java get class gives us a much richer structure. See, what Java's get class gives us is another object, right? And again, this is somewhat confusing, but Java uses a built-in type called class with a capital C to denote the type of this object. So remember that class object with a capital O is this root of the hierarchy, and now class with a capital C denotes generic information about classes. So I can find out information about classes in objects of this type. So what we're getting here is a class, what we're getting here is a class. Both of these are giving us classes, and now we're asking whether this class is equal to this class or not. So we can actually, so in this case we have actually used this directly as an equality, but we can actually define two variables C1 and C2 which are of this Java class type and instantiate them with the two classes of the relative objects O1 and O2 passed to this, and then check whether those two classes that get assigned. So this is just an elaborate version of the same thing earlier, except earlier we were not aware what that equal to is actually checking, whereas here we are kind of aware now that both of them are actually class objects and we're checking that they're the same class objects. Remember, this equality is going to be the reference equality. It's going to say that there's only one class object denoting these two and it's the same class. So Java actually does this implicitly, right? So for every class which has been loaded, so when a class is invoked as your Java compiler, as your Java code runs, it gets loaded into the runtime system. So every class which is currently loaded has a representation of its properties in an object of this type. So it's readily available to Java. So this is a way of taking some abstract information about the program, namely the class associated with different objects in the runtime code, and making them themselves into objects. So you can think about the kind of a recursive thing going on here, right? An object has a class and this class is represented in another object, and of course that object has a class, but then it's the same class and it stops, right? So we don't get into an infinite descent, but the main point is that you're taking something which is kind of abstract, which is the property of the variables that you are using in your code, and you are representing them as a concrete thing that you can examine, right? So this is a kind of fancy word for it, reification. So reification basically means representing something abstract as something concrete. So basically taking something and then putting it down in a place where you can actually examine. So now that we have this class object, right, we can do much more than just check whether two classes are equal. So once we have this class object, at runtime we can actually create new objects of a given class. So this is what we talked about in the beginning. So there are two types of things that you might want to do in a reflection kind of mode in a programming language. One is to examine things about what's going on. So that is what get class does. It allows us to examine at a given point what are the properties of a given object in terms of what class it belongs to. But now what we are saying is that depending on that, we can actually launch a new object of a given class, a class which we have never seen before, right? So we inherit a class maybe as a parameter in a function, and we can throw out an object of that class without ever having seen that class before. So there is this new instance function which allows me to take a C and give it, and of course, since I don't know in some sense what that class is, right? This new instance, I have to make it of a generic type object, right? Because I don't know what the class is, where it sits in the hierarchy. And then whoever is going to use it presumably will know what's going on and they will be able to change it. So we can also create such an object by knowing the name of a class, right? So for instance, if we know that there is a manager class, right? Then we can take the manager name and create a class out of it, and then we can create an instance of that class, right? So we can collapse this saying that we take the name, create a class for that name because we know that there is a class defined called manager, and then we make an object of that type. But remember that we can't use the string here because this is a runtime thing. The string manager is something which, I mean, right now it's a constant, but I cannot take the string and I cannot put in quotes manager and make it a manager. It has to be something generic. So at compile time, I should have used a generic thing like object, right? But at runtime, I can create specific instances of classes without knowing in advance which class it's going to be. We can do still more with this class thing, right? So a class, remember, consists of essentially three things. It consists of the constructors, which are used when we create objects of the class. It consists of the instance variables or the fields, which define the state of an object in this class. And finally, of course, there are the methods which we use to probe or update values of these instance variables. So for a given class, now what we can do in this reflection package in Java is to extract these details about these constructors, methods, and fields. So of course, a constructor, a method, and a field is more than just a name, right? So they also have their own structure. So if you look at a constructor, right, the constructor's name is fixed. Remember that a constructor in Java always has the same name as the class itself. However, it will have parameters in general. So it will have arguments. So if I get a constructor, I might want to know, is there a constructor with this type of argument, with that type of argument, and so on. If I have a method, well, I have an argument, but I also have a return type, right? Constructors don't return anything, they just implicitly create the object. But a method is something which takes an argument and potentially returns something. So therefore, I have arguments and a return type. And of course, if I look at fields, I have types associated with the fields. And finally, I have these modifiers like private, static, and so on associated with all of them. So all of these properties are there for all of these things, these modifiers. So in order to capture this information, I need more structure. It's not enough just to remember the name of a field or the name of a constructor, as we said. We need to know more structure. So therefore, we actually have now inside the reflection package, we have other classes. So we have a class called class with a capital C, which describes a class as a whole. And inside the class, we have constructors, methods, and fields. So we have another set of classes defined in the reflecting package to capture properties. We have constructor class, we have a method class, we have a field class. So for instance, we can use functions like get constructors, get methods, and get fields to return the properties of the given class in an array of the appropriate type, right? So here is a typical thing. So if I have a class, right? So C is a class. I have got an object, I have extracted its class in a variable called C. Now I take C and I ask what its constructors are. So this will return to me in general an array or a list of constructors. So the return type of this is an array of this constructor class. Similarly, if I say get methods, I get an array of this method class. If I get fields, I get an array of field class. Right? So we have these structured classes or objects which allow us to extract the components of a given class. So it's much more than just checking if two classes are the same, and much more than knowing the name of the class. I can actually get the individual components. And now, as we said, each of these individual components has its own structure, right? So they have their own properties. So constructor has arguments, each constructor in that array will have arguments, each method in that array will have a return value and argument, and so on. So for instance, I can get the parameters for each constructor, right? So I have this constructor array which I got here, and now I can say for every I, take constructors of I and get its parameter types. And this will now be what? It will be a list or an array of arguments, right? So the signature of a constructor is given by the types of its arguments. The actual names of the arguments are not relevant. You can use any name you want for an input parameter, but what you want to know is that this is a constructor which takes an int in the first position and a string in the second position. This is a constructor which takes no arguments. This is a constructor which takes only a string, and so on. So all these are different signatures, and each signature can be captured by the array of arguments. So you can get the arguments and store it. And now what are these arguments? So these represent types, and since they represent types, each of them is again a class, right? So we had a class, and then we had this constructor here, and now we have a list of arguments which are all again classes, and then we can again go into that and so on. We can ask what happens, what does each of the arguments look like, and so on. So each parameter list is a list of types, and therefore the return value is an array of type class, right? So for each parameter I get an array of class. So I get, in some sense, for a list of parameters I get an array of classes, right? So each constructor I gives me one array, and across all the i's I'll get an array. If I store them all, I will get an array of such arrays. So now, again, in this intercession mode where we can intervene and do something. So one thing we said is, given a class, we can launch it. We can create an object of that class. Now we can also change things in that class to suit our convenience, right? So for instance, we can take a method. So we have got the set of methods. So we can take method at index 3 and we can invoke it, right? We can actually trigger it on that object, and we can pass the things that we want to do, right? So in this particular example, so we are not using, so we have this class, we have this object, right? And then we have got its class, and from its class we have got the methods, and now we want to invoke method index 3 on that object. So we pass the object and the arguments to method 3 and say please invoke it. So really we are calling this method now like a function, right? Normally we would say object dot f something, right? So now we are saying f object, and that's something, right? So we are passing it because we are not operating on the object from inside as we would when we are programming it, but from outside, because we are reflecting on this data, right? In the same way, we can also take a field of an object and assign it. So we can get the fields of this thing, right? And then we can maybe get some information about one particular field, and then I can take another field in this object and set it to the value of, so I can copy the value which is there in field number 2 into field number 3. So these are all these ways of interceding, right? I can start with a class and create an object. I can take that object and I can apply a function to it. I can take the object and I can change the value of an instance variable. So sitting within Java, I can actually manipulate a Java program as it's running. So all of this works at what level? So does it allow us to look only at public information or at private information also? So we know that if we are actually programming in Java, then a class can only access public information about another class. It cannot access private information. Even a subclass cannot look at private information about a superclass. And this is the way of ensuring some encapsulation discipline across programmers. So people who are coding cannot violate this discipline normally. So it turns out that these functions that we talked about only return the publicly defined values, but there are functions in the reflect package which give us private values, because this reflection package is not really intended to be used to develop an application. It's actually more as a way of building things like debuggers and testing kits. So you want to check whether in the course of the program running, it is doing the right thing. So this is more like a higher level thing. So you have a piece of code which you're supposed to design to do a particular task. And now you want to be able to also validate that code is doing the right thing by asking questions about what is happening to the code as it's running. So from that perspective, this reflection is to be used by the person who has actually designed the code. And therefore, they have access to the private components by using these more elaborate methods called get declared constructors, get declared methods, and get declared fields. So this includes the public and the private, whereas the other one had only the public fields. So as I said, this is intended to be used by the designer of the code, and therefore it's more intended to use for internal validation, but can it be allowed to all programs? And now it turns out that Java does not really prohibit this. So if you use reflection, right, you can take arbitrary code and you can actually pass things around. If you can get access to something, you can inspect it in some sense. You can do a Java inspection from within Java using reflection. So there is some amount of security involved, because if this Java code is, for instance, something which is running on a web page or something, then a user of the web page can actually inspect what is happening inside the code and perhaps take some malicious action or do something based on that. So there are situations where you can actually define a security policy which is external to the Java code itself. So it's not something that you can, I cannot write in my class definition, do not expose this private, that is not allowed. Right? So I cannot really easily take a piece of Java code and say within this code, do not allow reflection package to look at this at all, no matter who asks for it. That's not possible. But you can write an external thing saying that because that's, remember that Java programs run in this JVM kind of thing, right? So they run in a controlled environment. So you can say that in this JVM environment in which the Java code is running, this is not allowed. These fields cannot be exposed. So that way you can control access, but Java itself internally cannot prohibit somebody using reflection from looking up private values. So what might be a typical use case for this kind of thing, right? So there is an interesting project which is called BlueJ, which is a programming environment to teach Java to small kids. So it's an interactive kind of IDE in which you can develop individual classes. You don't have to write a very full-scale elaborate program with the skeleton and the main and all that. So if you just want to define a class which does certain things with certain methods, then you can define it, and there will be a kind of automatic way in which it will be plugged in to something that can execute. So this is called BlueJ. So you can define and compile Java classes, right? And then you can run it like a debugger. You can click on it, create objects. So if you have used some of these programming things like Scratch and all that, this is a bit like that, but this is at a Java level. So you can create an object, then you can invoke a method on that object. So it's a bit like using an interactive debugger, but it's more intended for pedagogical reasons, for teaching Java. So you can create an object, you can say what happens if I call this function with these parameters, what is the current state of all the values and so on. So you can imagine that the way that such a package would be written would be to use reflection. So BlueJ internally is allowing the user to interact with the program like this by looking up whatever, because remember this is a general package, right? So BlueJ will take arbitrary Java code which somebody has written, and it will allow them to poke it, run methods on it, change values and so on. So clearly this kind of introspection and this reflection is being used inside BlueJ for this. So this is one use case. Other than debugging your own program, you can provide this kind of a wrapper environment where people can create Java code and experiment with it without going through the whole machinery of writing their own test code and so on. So you can look at this URL www.bluej.org to see more about BlueJ. So one of the things that you cannot do is to create new classes, right? So what we can do in Java reflection is to take the existing objects that are there and get information about the class and then do various things with that. We can get information about the constructors, the methods, the fields. We can apply, we can create new objects. So we can implicitly call the constructor. We can explicitly run a method. We can explicitly update a field and so on, right? But if I want to create a new class, for example, in BlueJ, right, I can take a class which I have written and then start playing with it. But if I want to add a class, then BlueJ will have to kind of use the Java compiler to include that class. BlueJ on its own, while it is running, cannot incorporate a new class into the Java program. So you cannot at runtime generate a new class. You can generate objects of a class, but not the class itself. The class itself has to go through Java compiler, which will then check various things about it. So in contrast, in Python, if we use a class definition, right, it's an executable piece of code. So anywhere in my code, I can see if I run across a class definition, it will create a class. Right? So classes can be created at runtime in a language like Python. So this is not possible with Java. Other languages also, so there is a very, we talked about Simula as one of the pioneers in object-oriented programming, but the next big language after Simula was Smalltalk. So actually Java inherits a lot of features and a lot of experience from these languages. So Smalltalk was a very pioneering object-oriented language which was developed in the 1970s at Xerox PARC. And in Simula, for example, you can do this kind, in Smalltalk, you can do this kind of runtime modification of your code. You can create methods and so on, very much like what Python can do. So Java reflection can do a lot of things, but it's not universal. It cannot do everything, but it's very useful in order to be able to do these kind of introspective programming, to find out what's happening in your code and to modify it and make changes and experiment with it. And especially for debugging typically, but also for these languages like this package like BlueJ, to teach Java, you can use it.